Hi, my name is Suhan, and this is my submission for this year's HackAMind challenge. My project is called NeuroBalance. NeuroBalance tracks inevitable eye loss coordination for patients with Parkinson's disease to provide insight to healthcare professionals. Before we look further into NeuroBalance, we must understand the basics of how Parkinson's disease causes visual degradation. Parkinson's disease alters normal cerebrospinal fluid, or CSF, circulation in the brain. Impaired CSF flow disrupts waste clearance and nutrient distribution for neurons. Changes in CSF pressure and composition contribute to neurodegradation. Motor symptoms include tremors, rigidity, and slowed movement. Non-motor symptoms include cognitive decline, sleep disturbances, as well as mood disorders. Monitoring CSF dynamics can provide insight into disease progression and treatment response. So what can we do to help? The solution is NeuroBalance. A one-of-a-kind software, NeuroBalance allows doctors and scientists to track eye coordination of Parkinson's patients over time in a fun, fresh environment. Some of the key features include interactive balance training game, which is designed to assess and improve motor control in Parkinson's patients, real-time tracking and feedback on balances, reflexes, and coordination, insights into neurological health by monitoring movement patterns linked to Parkinson's disease. How NeuroBalance actually works. So on the left side of our screen, you can see the game UI, and on the right side, you can see the session results, where it has the latency, the accuracy, as well as the drift. So once I start the game and it calibrates, those three dots that you saw on your screen are essentially where your eyes are supposed to go, so the computer knows where your eyes are tracking. Next, you can look around all over the screen and track the ball. So when you're tracking the ball, the paddle moves as well as you can hit the ball. Once you're done with that, you can click Compute Score and you'll get your scores. I got a green, which is low. That means my score was good. Affected as NeuroBalance function. In short, it uses a WebGazer library to track eye movements. All the vision that we used in this project happened only in the web, so it wasn't transferred anywhere else. It also used React and TypeScript to create a Pong game. Additionally, it integrated eye tracking data with paddle controls, and it tracks the eye's latency, its drift, and its accuracy to determine a severity score. The severity score ranged from three different categories. The first category being green, which symbolized that the patient's or the user's vision was perfectly fine, yellow meaning that it was at a medium level, and red meaning that it was very severe. Now it's time to take a look at the code. So this first file that I've pulled up is called app.py. And what app.py does, it essentially allows the backend Flask server that runs the API. It processes eye tracking and game data, as well as it sends results to the front end. The second file, page.tsx, is the main entry page that loads the NeuroBalance app interface and mounts the game. Then we have game.tsx. Game.tsx contains the Pong game logic and rendering, including ball movement, paddle control, and score display. Then we have layout.tsx. What layout.tsx does is it defines the overall structure and consistent layout of the app. This includes wrapping header, body, as well as the footer. And finally, we have webgazer.ts. Webgazer.ts is a custom React hook that connects the WebGazer library. It tracks eye movement and streams gaze into the game. This is essentially what brings the entire game together. Without the WebGazer library, none of this would have been possible. Like any project, NeuroBalance faced some setbacks. The first of these setbacks was in visual input and control, where the program wouldn't detect blinking and it would crash if the user looked away. To fix this, I added redundancy to the camera vision to ensure that this wouldn't happen. The second one was the paddle movement was choppy. To alleviate this, I fine-tuned various parameters in the WebGazer file to ensure its smoothness. The second grouping of problems was the front-end to back-end communication. Data from the eye tracker was not syncing correctly with the backend, so I implemented a structured API endpoint and validated requests before processing. The second problem in this was that the session results sometimes displayed outdated values in the front end. So I added real-time state updates, ensuring consistent JSON responses from the backend. While NeuroBalance has made incredible progress over these past 2 days, its work can still be broadened to help more people. First off, I plan to track severity scores over time to predict whether a patient will show positive or negative symptoms in the future. Additionally, I would like to improve the eye tracking algorithm further to ensure all edge cases are covered. I'd like to expand this application beyond just Parkinson's disease, but also to child development to ensure the child is developing adequately. Finally, I would increase game variety to track different data points for healthcare professionals. Thank you.